I'm reading a lot about personality types. And I think those are driving the relationships more than the industry itself, right? So if you have personality type X as a contractor, as an architect, as a developer, they will act and behave and respond to others in that way. So trying to understand those personality types and understand that that's why they're reacting the way they're reacting makes a lot of sense.
It gets me every time because someone has to do that to do the rest of the cladding on the building. Actually, to do the superstructure itself, like you need to evaluate the loads on the building. So someone's doing it, but then it always comes to glazing contractor has to redo it. And I'm like, why? like you're already doing it. Like just share the info and then we'll all be aligned, you know.
So we're going to start this new series as Chatting with Friends. And the hilarious thing is this conversation was sparked by Manny, who you could see is in clearly a cooling dominated climate, having some strange desire to talk about passive house construction. So I don't know if he either read the wrong definition of passive house in the dictionary or if there's something actually worth uncovering. But let's start there, Manny. Why do you care?
I think I blame you for a lot of the things I do lately. I think I sent you a message the other day. I said, hey, look, I'm posting this content. Actually, I'm doing an AIA presentation. And even the sequence of that presentation mimics our first podcast that we did. I think it was your episode 10. So with stuff I was explaining to you, I'm like, well, wait, everybody's asking me the same questions. And everybody's kind of has the same misconceptions of what it is to get let's call it an impact rated or hurricane rated system. In my opinion, it was very simple. When I would hear you guys talking about sustainability and energy efficiency, it felt complicated. I said, why do they know something I don't know? What is this thing that everybody in the South just says, we just don't do that down here? It just didn't make sense to me. So I started researching and it's like, how far can I take this beyond, I studied LEED maybe 10, 12 years ago. It just never clicked with me. This whole point system, all this, print all these manuals, and then it just didn't feel like it was generating much of what it was supposed to generate. And the more I looked into passive house, it was like, wait a minute, this does make sense. You're trying to make it sustainable. Looked at Passive House Institute, looked at Passive House US, and then when Passive House US says, well, it's not really for heating dominated climates, it's for any climate if you do it right. Then I said, okay, maybe we're onto something. So that was really it. It was something that apparently smarter people have already figured out can be done anywhere in the world. And yet, if I were to start anywhere learning about it, I said I want to start all the way at the end, basically, even if I'm not going to end up applying it to Florida. I don't think there's a local, certified passive house consultant here yet, at least Miami and Broward, to put it that way.
Well, we've sort of spoken about it in the past. How do you develop an effective international or nationwide building code that can be applicable to all climate zones? Because all of them have such independent, respective needs. And sort of a little bit of a top of mind conversation at the moment is, I'm weighing in my head a lot, sort of the viability and future of aluminum versus UPVC or alternate material windows. So you see this huge push in the Northeast and even places in the Midwest that a lot of multifamily buildings with smaller punch size windows are going to UPVC. So historically, there's a lot of pushback from the aluminum industry that you didn't get the similar strength and durability that you would with an alternate material that you do with aluminum. But then on the contrary, they're saying, but you get superior thermal performance. So kind of depends what type of application we're talking about. But let's start there. When you talk about sustainability and performance, really, it's like, well, what are you talking about?
We were getting questions about UPVC. We've seen it in our market at this point. Hurricane rated PVC windows, floppy. There's a few questions that come to mind, and again, this is not coming from a need to be sustainable. This is coming from a need to say, we're envelope consultants yet we don't understand sustainability. That didn't make sense. So we need to understand sustainability. So life cycle and life cost analysis for UPVC, I don't know if it's there where, I'm repainting aluminum windows, 20-year-old aluminum windows right now, and I'm resealing them into barrier systems. So I've just extended that 10-year product, made it to 20. I might give it another 20 years now, the same aluminum window. Can I do that with UPVC? I'm not sure. I don't have the experience with it. I don't know how it's going to fare in our UV. I don't even know if I can paint it after the fact. So I think about PVC roofing. If it's not like a KE system that has, these special plasticizers that extend the life of the product, I don't know that the PVC windows are there yet. As far as strength, my experience, unfortunately, has been leak investigations with PVC windows, where The moment you start drilling into them, they start bowing and flexing, or they're putting screws in the wrong place because they weren't supposed to have screws in the sill. Once you damage that extrusion, there's no fixing it. There's no Bondo. You can go back in. I don't know if they've come up with some melted PVC or something that can go back in there. That was a nightmare. We had every single home window leaking throughout that whole property, and we couldn't find a solution for it other than to say, we think you need to replace the window.
So a lot of the lens I try to look at today is designing for future replacement or maintenance. And I'm a little bit all over the place, but I had another recent conversation about the viability of vacuum glazing. And of course, the conversation always steers towards, can we salvage the existing framing and just replace the glass? And in a heating dominated climate, you'll typically run into an issue if you don't have a substantial thermal break in the frame, just because that's where all your heat transfer and condensation is going to occur at the edge or at the framing members. But never really do you run into issues where people say the steel or aluminum framing, you do, but the majority of the time, they don't say that you're running into structural issues. So typically you'll be able to withstand multiple life cycles of IGUs while still utilizing the framing members. So now I'm going to turn it to Spencer, and we can talk a little bit about Passive House, but more from the balancing of thermal performance cost, but also durability and longevity. Where do you see UPVC and alternate materials playing a role in all of this?
Yeah, I think that the experience that I've had with it really more from the direction of the higher end performance PVC, because obviously vinyl windows exist, in abundance around the country for like single family home applications, and they have for quite some time. But I think when we start to talk about, commercial applications or multifamily or specifically applications where there's really high wind loads and really deep glass packages, right? Then you kind of start to push yourself in the direction of like more the European framing style. And, honestly, it's such a cost driver to try and incorporate like a, in the colder climates, like a better performing window system. As you were saying, Adrian, you need like these thermal breaks. You need like a very robust barrier in an aluminum product, but you can get an equivalent PVC product for residential application at like a fraction of the cost. So I think that's, it's kind of a, that barrier to entry is a little bit different, but I've always looked at it as fundamentally like a very different application. There's been a few projects in New York, like larger passive house projects that have utilized PVC windows in mass, and it always makes me kind of nervous, when you see that, because the durability piece is real. And I think when you look at like the life cycle of a multifamily building, that long-term maintenance, that ability to renew, replace the glass, maybe refinish the windows, as we were discussing, is super important. And I think that issue, is even more important the more like, exposure to UV that you have, so in a southern climate, I mean, there's things you can do with vinyl windows, like you can clad them with aluminum, right? So that's like a strategy, but then like your cost delta it's a different equation. Like you now have a more expensive vinyl window, and then you have to ask yourself, like, is that really a benefit versus just using a deeper thermal break on an aluminum system? And the thing that's crazy with the PVC windows is that structurally, it's all based on the reinforcing. So with the aluminum product, you can integrate like the structural diagram into the section, into the extruded profile. But with the PVC, you're just loading the system with steel. So depending on how you connect to it, depending on how that steel is fastened to the profile, is fastened to the anchorage, right? Like it can get complicated. And I think it becomes, kind of a risk factor, also for super, super high load environments or impact loads, right? Like you're obviously still going to use structural silicone, but, I think that there's like a reassuring durability if like the primary structural material is the framing and it's not something inside the framing. It's just a little bit different, more effective utilization. But I mean, look, at the end of the day, I think it's really mostly driven by cost. Unfortunately, it's like this whole mentality of trying to lower the price as much as possible for the initial construction and get like this higher performing benefit. So, you're always going to have that at play.
Let's just really have this conversation be based around either for us mid to high rise where we're imposed or exposed to higher wind loads, and then any project man he's going to see where he's in a hurricane zone. I hear what you said about loading it with steel. I think that's typically the solution on taller spans. I see a lot of these suppliers now coming out saying we could do window wall or curtain wall, and your primary concern is how is that assembly behaving as a composite? no matter how much steel you're putting in it. But on the contrary, what happens when you use an aluminum window with a thermal break that's too big, and all of a sudden you're relying on that plastic component to behave over time? Is that an additional risk that needs to be considered too?
I mean, it is in some configuration. We're kind of getting into the nuance here, but I think the fundamental difference is that, aluminum you can configure like a curtain wall product, right? So the way that the glass is retained in that approach, like in a curtain wall approach, you can use structural silicone bonded directly to the aluminum frame. And, the thermal break is part of that in some cases, but if you have that structural silicone, especially for an impact environment like that, that's a really effective like structural diagram. And then the other is that if you've got cover caps, you can have mechanical fasteners. Like they go through the break area, so they're technically a thermal bridge, but you kind of minimize the damage that they do, to the overall U value by insulating them and using kind of clever details at that connection to, prevent heat loss. But yeah, like in a typical window where you have a strutted system, right? You absolutely need to take that into account if it's like a really big span, right? But then that's the difference is that if you're going to be doing something monumental, right? Whether it's like a unitized curtain wall panel or ground floor like podium, you'll be going the direction of curtain wall anyway. So it kind of gets back to like, what's the application, And I think there's this maybe like dream that some, builders and developers have. They're like, oh, well, if I can get good performance and use PVC and keep my costs down, I just push the PVC system to the limit. Like, what's the limit that I can get to before it's like, beyond what the product can actually accommodate or what's reasonable? And yeah, I mean, it's it's a little dicey in my opinion. Like, yeah, you can calculate a composite, right? But then if you're fastening all this stuff together, if you're relying on like field mulling these PVC windows, like your installation now becomes critical to the long-term performance of the system, even more so than what you have with aluminum, right? And that's always higher risk, right?
Are any of the UPVC suppliers structurally glazing, from
For
what you know?
impact, yeah, for impact rated areas, you use the structural silicone, but you
It's
Can
so
you
can't
get
captured.
really.
away with the right design in a dry glaze configuration?
I suppose depending on the loads, you could, but what I'm not familiar with is like the failure because when you do the impact testing, right, you're actually, you know, you're testing the frame integrity as well as the glass, right? So with aluminum, it's like you have a little bit more of a safety factor there because the aluminum's not going to shatter, right? Whereas certain vinyl products, like you have the possibility for like structural damage on impact that's more significant than it would be with aluminum. But I think it really kind of comes down to what the targets are, you know,
The
what level of
hilarious
impact
thing one day
resistance.
is when Spencer's gonna be representing a vinyl or UPVC company, and I'm gonna reference this back, and he's just gonna get fired on the spot. But I'm without naming any names, some massive players in the industry have pivoted or sort of added UPVC to their repertoire, which has surprised me. So obviously they see that as the direction that the industry is heading. Is that what you're seeing, Manny?
I see there's a market for everything. I think Spencer's first point of residential versus commercial versus high rise definitely has to be considered. If you're doing a single family residence, maybe even luxury, you do, wood clad or aluminum clad windows, it's worth that discussion. Once you go into kind of mass producing, and there's something in there he said about essentially you're leveraging risk. Yes, I'm saving some money. How much am I increasing my risk by going to the system? Is it really worth the money in the long term? Be it from the material or be it from the improved thermal performance. When you were saying, and that's the question I just got asked last week about somebody competing locally, I think it was in Tampa project, with PVC windows, with steel reinforcing. And I immediately said, well, what's going to happen when all that steel rusts, basically? Because, again, South Florida is designing barrier systems. Even if they're drainable systems, how are they managing to keep that steel in the dry area if it is basically a steel frame cladded with PVC? So that kind of triggers a lot of red flags. We I think again, this is something we talked about a long time ago, maybe you, me, and Elliot, Adrian, and it was about the labor pool as well, right? If it's not something that anybody can pick up and install, then that risk goes higher. And PVC seems to be something that, especially the locals, if they really know what they're doing, they probably wouldn't want to touch it because it just behaves differently to an aluminum frame. Structurally, I mean, I could go all day with structurally. What Spencer mentioned about impact, large missile impact, they're going to shoot straight into that mullion, right in the middle. And that is the proof of the large missile impact. They want you to shoot it and then cycle it and show that it didn't buckle after shooting it. What if you essentially break it and then forget about buckling? It could be total collapse. So I'm not there. And then if you look at what are you getting from a PVC window that you're not getting from an isobar with an aluminum frame with insulated laminated glass? I don't know that the gain is that big. It may be that it's on the specs somewhere with like a prescriptive value saying, here's the value I want, give me that. Nobody's coming back, which is why I said I needed to go back and study this because I couldn't argue it. All I could say was, that doesn't make sense. Why am I doing that? Well, prescriptive says this, and mechanical, that's the value he used. When you go back to mechanical and ask him, well, do you need this value? He goes, no, well, nobody gave me a value, so I use that one. And that's what my calcs are based on. And if you give me a different value, I'll have to calculate it again. Like, yeah, but that's engineering costs versus material and life cycle costs right there from one quick run of a energy analysis. It's a long conversation of that. I think you're doing your part of how much education is missing, right? From structural, from MEP, from envelope, from water. There's a lot that needs to go on.
I don't want to downsell UPVC because I think it has its place. But one thing that I do notice is that I really often don't see UPVC specs. It seems as though it's always a VE alternate to steel or aluminum. And then a lot of times I see it's sold directly to the GC and they have their carpenter put it in. And so all of a sudden now you're eliminating that skilled labor component. But I don't know if there's any additional challenges with installing it in the field that would make the installation component become even that much more critical. But to kind of play devil's advocate, what are some of the upsells of UPVC? Other than saving cost, what is it that it can provide that a steel or aluminum assembly or unit cannot?
I can only think of the thermal benefit, basically. I mean, it's and then if you're thinking about from a materials perspective, I think both of those are considered somewhat toxic. So there's a whole side of is it a toxic material, and which one's recyclable.
Why is so? I can understand the cell in a very northern climate where it's cheap, performs great thermally. You can get a higher window to wall ratio, great. But why are you seeing it in the south then? Is the actual raw material itself that much cheaper? And in that event, like is the labor to assemble it that much less? Like what are we missing here?
I can almost guarantee this is a question on a project we were not on. It's just somebody that said, I need your help. I'm getting asked to do this, and this doesn't make sense. And when they asked, I said, where's the architect from? And they weren't from here. So you get specifiers that are not from the South, specifying products and performances that are not from the South. And it's not just Northern architects. I mean, we have architects, we're working with architects out of Europe and the UK, and it's always the same question. It's like, what are you guys doing? Nobody does this. Well, it turns out we don't have to because we're a cooling dominated climate, and this is really what our risk is. You talked about, I think we talked about condensation at some point, and you had a whole post on it. We have condensation constantly, but it's exterior condensation. It really will be impossible for us to control it. Meanwhile, you're doing PVC and thermally broken system to not just give you a better thermal performance, but to prevent interior condensation and mold growth on the inside. Our mold growth is coming from poorly designed walls, not no interior mold from windows other than the ones that are leaking, like bulk rainwater, basically.
Or the interface and what's happening behind the drywall that you can't see.
So again, it's almost like we should do all of these with a cut section and start pointing at it. You're seeing your steel all the way on the inside. We're seeing our steel all the way on the outside. Right. So that's it. There's no air seal inbound of the window frame in most of the barrier system. It's just one seal on the outside. That one has to pass. We may push for double seal and then weep that secondary seal. But that interface is happening basically on the water shedding plane of your WRB, your weather resistant barrier. So you're not risking bringing moisture back to that drywall. The risk comes in doing vapor barriers, basically doing internal vapor barriers, which again, for you guys, it's fine. Our code says you are not allowed to do a non-breathable coating on the walls. And again, I see specs with, foil-faced insulation because the insulation company said, yeah, this is great. What is it? Radiant thermal barrier, but it's non-permeable. And again, the code says, at least for our climate zones 1 and 2, you're not allowed to do, class 1 vapor barrier, or class 2 even for that matter. So again, I'm going to go a lot back to lack of knowledge that, and I think Elliot used bias as well, where he said, look, it's the bias of where you are used to working. If you're used to working in a climate, whatever the other people are doing, it's not going to make sense. And then now that there's cross collaboration, I don't think there's I don't know if the word is a mediator, but almost like a liaison between the north and the south, right? And the heating and the cooling climates. And again, we found this ourselves. We didn't have anybody that I could ask, well, why do you do it this way? We had to go find out for ourselves why you're doing what you do and why we do what we do. And kind of works, could be better. Hopefully we'll get better.
Do you have a lot of architects, and I'm assuming yes, coming from other regions, and in that instance, they're playing the role of design architect, but do you have a separate architect of record that's local that can help with some of this, or are they heavily relying on you?
We're seeing both. We're seeing design architects from all over the place, and I'm seeing architect of record both, from California and New York, and then locally. So we do have to have these conversations. We just did a lunch and learn for a team, and they had team members in Chicago, Tampa, and Orlando, right? So, and I asked the question, I said, where are you guys doing most of your work? And they said, Florida. We're doing, even the Chicago team was doing a lot of work out of Florida. I've seen, best case scenario is when you talk to them, they've already done that research and they understand the differences between the two climates, because really climate is what's driving the design. Worst case scenario is they haven't, there's no envelope consultant, and the building is 10 stories up, waiting for the framed walls in the middle of Fort Lauderdale. And everybody's looking, where are the walls? Oh, they were supposed to be stud framing. Okay, what are you doing? Oh, we're just doing it. That was a disaster, but other discussion. So it could be disastrous in the short and long term if you're stepping outside your typical design zone and you're not doing the research. I think you could walk yourself and your client into trouble.
Where do you see your efforts having the most impact in terms of, I see you trying to spread the word either publicly or privately behind closed doors, but who's listening at this point? Who cares?
Architects are. Going back to the sustainability question, I think I mentioned to you last time, there's maybe 2 or 3 that even care, but they all want to stay out of trouble, right? So when you're telling them, yes, you're designing for sustainability, impact rated, you're designing for resilience, but you're also trying to stay out of trouble because this wall performs better, this window or this roof performs better, they're listening, right? Because it does make sense. Once you explain to them how it's supposed to work, then they go, oh, okay, I'll correct this, and I'll correct it from here into perpetuity. So all of the architects are listening. The impact, I think, is twofold. If we were to say, because we're buying the risk too, right? So as I'm picking clients, if I'm going to pick a client that's never done work in South Florida, or let's say they have been doing work in South Florida for 20 years, yet they've been designing not in a great way, it doesn't really do me any good to pick a bunch of their projects. It does me better if they improve on their designs and we're all staying out of risk and we still get paid for our services. That's what makes more sense.
Do you use like modeling tools to kind of validate your concepts? I mean, it's really common, I think, more in the passive house community for like, Woofy and other, applications to simulate, where the dew point is in the wall assembly. I mean, is that part of your kind of standard practice, or do you just go with local means and methods that are established and you just say, hey, like, this is what's been working. We know this works for this climate zone. Just kind of fall in line and let's do what we know works.
It's worse than the latter, basically. So here's what we've been doing and it works because we as an industry are addressing bulk water. So this doesn't leak, but air, vapor, and temperature, we're not properly addressing, or haven't been historically properly addressing. I can say it's getting better. As far as the WUF analysis, that's why, we're going with like studying, building science, Joseph Steelbrook and those guys, basically saying, okay, what do they do? And there's builders, guys, hot and humid climates. They're basically saying, if you do this, you don't have to do a WUF analysis. Just let the wall dry. So both on the outside and the inside, expect that there's a high humidity ratio, especially after a rain event and the sun comes out, it's going to be very, very humid outside. So the vapor drive is always going to be playing around with that wall. Just let it dry out.
Right.
Then when we get to the roof, it gets a little bit more interesting because now I've got, for example, a corrugated metal deck with a solid non-breathable roofing membrane. But again, that has worked historically for many, many years. So it kind of counters that perfect wall design for the roof condition. I haven't seen, I think I know one local expert that does woofy, and every time I tell them, I go, is it really worth doing? If you understand what the wall is supposed to do, you probably understand that you don't need to do that woofy analysis. So when it comes to passive house, it's different because you're looking for that, that thermal bridge, that condensation point. Is it beyond a certain range?
Yeah.
That goes well above at least our local code.
Where do you see the significance right now, or the disconnect when it comes to structural engineering these assemblies? And it seems like there's so much focus on air, water, vapor, thermal, but going beyond just following a spec section, understanding like how much movement is this storefront system supposed to accommodate your window walls, your terrace conditions? How come it's overlooked? And I mean, that's ultimately a life safety issue, but there seems to be a huge disconnect between the structural engineer of record and the glazing structural engineer taking liability.
I feel like I pick a fight on every podcast. And I think, Spencer, you were going to ask a question, so if you can remember what it was. So what did you say? Most of your buildings a lot of your buildings are punched buildings, right? And even the ones that are window wall, you'll have masonry adjacent. At least for us, it's going to be masonry walls adjacent. Even if it's stud framing, how much movement can a masonry wall accept in your experience? You know, it's a half-inch grout pack joint. If you're doing a stud frame wall, there's no typically slotted connections. It's simply a track with stud framing and sheathing. How much movement can those accept? And then the facade and window industry has to take all of the movement, basically. So now all of a sudden the window needs a head receptor, but the CMU wall adjacent to it doesn't. So I have a bone to pick with that, right? The experience is I haven't seen 20 years doing this, thousands and thousands of window systems inspected, engineered. I haven't seen a window system fail because the slab above over deflected. The only times that I've seen issues have been substantial differential settlement. So one side of the building settled, essentially crushed the head receptor. There was a head receptor window, or essentially shut the window frame, the door frame into the panel. Those doors we couldn't open and close. But for the most part, you know, what you expect is that every floor is deflecting similarly, and then you're going to have some hot spots when you go from like a podium level to a typical floor. Try to explain that to somebody writing specs. They're going to put in there and say, you need your thermal, difference of, 100 degrees Fahrenheit, and then you have to take in, 3/4 inches of movement because, Elber's 360, and just like a random number that they throw out there, and it's only applicable to the glazing systems. And then it drives me insane. There is definitely a disconnect. So when we're working very early on with the structural, and then a lot of systems we work with have integral head receptors. So there's a limit to how much they can move before they disengage, or if you're doing like an F or T clip. And then we tell them, we say, hey guys, it's really live load deflection that's going to affect us. And we walk them through what we need. And then they come back and say, oh yeah, that's true. Here it is. Here's the live load. You guys do the math of the differential. And we find that most window wall systems that have some kind of slip connection are fine, right? But if you read a spec, it would tell you that unless you're doing a chicken head or a curtain wall system, nothing can accept the building movements in a high rise.
Yeah, I'm talking, yes, all the above, correct. Maybe, and take it to the next level, like how many of these buildings, and I'm assuming the answer is the monumental ones do. And really, like, let me go on an aside for a second. I post about this stuff, having the sealant manufacturer come out and do adhesion testing and blah, blah, blah. And then I'm realizing, like, okay, this stuff happens when you're doing the monumental perma-lisa curtain wall job, but on your run-of-the-mill job, this, Spencer, on a ton of jobs, Dow's not coming out and doing adhesion testing and warranting it. So what, like, sealant principles don't apply on a 20-story building? So I would suspect a project-specific wind tunnel study would be done on one of these monumental projects we're looking at behind you, but everything else just gets like a standard ASCE 7. And ultimately, is that adequate? Is that enough?
I think the sealant question, it's an important point. I think it becomes interesting when you talk about kind of established means and methods versus project specific certifications, right? And it kind of ties into what we're talking about with the structural too. Like, some projects, they don't want to go through all of that. They don't need it. It's not in the specification. Maybe it's a smaller building. The use case is not as like, high risk or extreme. So you might say, well, we've used this sealant with these substrates in the past, no problem. Or maybe here's a reference adhesion test we did for another job. We're just kind of qualifying it with that, right? But then you'll do like a monumental building, same substrates, and they're like, we need adhesion testing. Have to have it for this project. It's like, okay, we've done this like maybe 100 times, but sure, here's the window frame again for more adhesion testing, and not to belittle the process, but it kind of becomes redundant in a certain way, and then the structural piece, like it's so specific to what I find the building superstructure engineers like mentality, and the way that they're kind of like framing all the conditions. I think that, yeah, generally, like it's always super vague in the beginning for whatever reason, and then we always have to drill down. And what we find is that the requirements initially are like ridiculous. It's like, oh, if you actually go through and follow live load, long-term creep, interstory drift, I've got to accommodate like plus or minus like 2 inches. And it's like, this is crazy, and then you have a coordination call, submit an RFI. It's like, oh, actually, it's just plus or minus half an inch. Like, It's like,
but you're the contractor, you're already on the project. So they went
yeah,
through a
right.
full design process with this as the basis of design.
Well, and I
Yeah,
think
but
there's
don't
such
you
a
think that's because the
disconnect.
baseline standards have a huge factor of safety in them, given everybody's trying to offset risk, the mechanical guy, the structural guy, the facade guy, and you don't have that collaboration. So Spencer, how many projects have we worked on where we're like, just give us the design pressures, and they're like, here's the structural drawings, and we're like, no, the cladding pressures.
Yeah.
And so unless all three are working together, think about how much, extra fluff is set in those construction documents.
Well, and how much is being like repeated? Like it's so funny to me that like I understand the mentality. The building superstructure engineers, like we have to like, set up the general parameters for the project, get it going. Okay. But like tolerance control for like the concrete guy versus the glazing guy, like plus or minus 2 inches for glazing that's like that's like different universes than plus or minus half an inch, right? And I think there's kind of a misunderstanding about like how glazing systems can accommodate some of these variables, and like the range that's like standard. And then yeah, for the cladding design pressure, I mean, it gets me every time because someone has to do that to do the rest of the cladding on the building. Actually, to do the superstructure itself, like you need to evaluate the loads on the building. So someone's doing it, but then it always comes to glazing contractor has to redo it. And I'm like, why? like you're already doing it. Like just share the info and then we'll all be aligned. Not to say if you give me the inputs, like I'm going to come up with something wildly different, but still like there's always a little bit of risk that like some assumptions might be incorrect, or maybe it's a complicated building geometry and it's misinterpreted or something. It's this weird dance. It's like every job. I don't really understand it. Yeah.
The silver lining is I can't take it personal because I thought this was something, of South Florida, and you guys are going explaining exactly the same issues we find. And, a building that is in concept design, they know how many stories, they know the floor plan, give me the windows. And we're having as a facade consultants to run our own windows saying, here's the disclaimer, you need these from structural, but I can't check glazing systems without these pressures. You can't go prices. You can't design the building, size panels. You can't really do anything without these pressures. And these are world-renowned 40, 50-year-old structural firms that aren't issuing this information with their first concept design. They have to wait for somebody to beg them for it. The sealant question you mentioned before, the funny one is I talked to the manufacturer and they say, hey, our product can give you a 20-year warranty. We're only going to give it to you if you ask for it. I'll sell you the product. If you don't ask for the warranty, you don't get the warranty. So if they don't ask for the pull test, if they don't ask for the warranty, that guy just told you all the product for zero liability, basically, because you didn't do your part. And then you mentioned the pull test. Again, they have stories about that, saying, okay, maybe on the window system, not so much, but on the substrates, they had a project where just water was seeping up through the ground and they were failing pull tests, right? So again, it's a free test. It takes seconds to do, and it could. This is one of the things about that liaison, right? You guys, as cladding and facade experts, you will take care of yourselves and you will take care of your client to the limit of whatever your product is. But when it comes to the rest of the building, it's not your place to do that. So that's why I think clients are wise to have a facade consultant, because that guy is supposed to connect the window guy to the wall guy to the waterproofing to the roofing, and at that point say, I need more information. I'm not getting the warranty. The client's getting the warranty. When they say, do you approve this? I'm like, I don't approve anything. You want to make sure you have it because later you want to go back to the manufacturer and say, your product, in fact, did fail because we did everything we had to do.
I think the crux with being a customer-oriented company is that people sort of expect you to dance or play outside of your lane. And yeah. I mean, Spencer, you're going to laugh at this. You'll know who I'm talking about. But an individual went to a plant yesterday and he said, oh, they were putting in the caulk beads and they look nice and they actually were adhering. And I'm like, that shouldn't be a surprise in a controlled environment like that. But that's what we've come to. And ultimately, like, you, Manny, are forever going to be the annoying guy repeating the same principles until it hits home.
And again, there was a little bit of hope when you guys were complaining about the same things, and then there was a little bit of sadness because it's never going to get better. Again, if you're looking at firms, both from the design all the way to the GC to the manufacturing, that still have to be told this over and over again, then we're never going to 100% fix it, I guess, is really what Elliot would say at this point. So you were mentioning the fact that the structurals, there's a safety factor, but there's also the unknown, right? What I've talked to structural engineers is, hey, I cannot predict long term. So I just take whatever ASC 7 tells me and I multiply it by, I think it's like a 2 times or a 10 times multiplier for the duration of the load. It's not a real number. It's just something that is in a book that says, let's design for this. But my pet peeve is that it's only being enforced onto the glazing systems, not enforced to these partition walls or any other wall.
But when you're dealing with the monumental unitizers that really have this stuff down. Like you don't need to explain what a butterfly test is, and they just do it. Does that then open you up or allow you to focus on like more interesting, important things? Do you think we're just bogged down in our industry by such nonsense? Because these things are just not being embraced, that it's what allows some of these companies that actually have the process in place to do more monumental work and push new limits?
I would say that if the contractor can't teach you something, then it might not be the right contractor. Right? Like if you have to teach or explain something to the contractor, that's a red flag. I immediately go back to the client and go, look, I'm asking these questions. I shouldn't be asking questions. They should be submitting these butterfly and the snap test reports, right? They should be submitting the manufacturer's quality control procedures. In fact, it's in the code. And again, you'd be surprised where, oh, I have to do that? Whoops, I didn't do it. Let me go back and do it. Automatically, you tell the client, you gotta be ready. But then the client comes back and says, well, he's the cheapest one, so what do I do, man? And it's millions that I'm saving. You need to help me keep them in check, kind of deal. So I'm here buying risk for the cheap window manufacturer.
Spencer knows I am, the biggest critic of us, but if a facade consultant has to come in and teach us how to build a window, or any supplier, you got an issue on your hands. So yeah, no, I think it should be about elevating one another. But unfortunately, that's not what it's become.
So what else did we not talk about today?
Oh, there were so many directions we could have gone. It's just, I just kept interrupting. By the way, I'm drinking out of a straw now because my wife says I'm aging too quickly, so I need to relax more and drink more water, and the stress is getting to me. So that's where we're at now. If you want to run away from this industry, this is what's coming.
Somebody just told me yesterday about meditation. Somebody my age or younger. My dad's always told me about meditation. I was like, a shock. And now I talked to this younger guy yesterday, and he's like, yeah, I meditate 5 minutes a day. I'm like, oh, okay. I guess I should consider it because I'm very high strung. So we're
yeah, I think it can. I was talking to a contractor this morning, and we're talking about the markets and products and blah blah blah. And maybe you could consider a competition. And he goes, yeah, this world is just like a dog eat dog world. And like, is that just the reality of the construction industry? And maybe Spencer and I are a little too deep in the contracting side, where you have a little bit more of that ugliness. But do you think, just to reflect on your experience from the other side, on the design side of things, is the landscape a little more friendly? Do you think it's like a little more kind of sustainable from a stress management standpoint?
I think I'm talking and I'm reading a lot about personality types. And I think those are driving the relationships more than the industry itself, right? So if you have personality type X as a contractor, as an architect, as a developer, they will act and behave and respond to others in that way. So trying to understand those personality types and understand that that's why they're reacting the way they're reacting makes a lot of sense. At that point, it's not about knowledge. It's not about the firm's capacity. It's about, the personality types that are running that culture. So I know firms, competitors that are very, very, very collaborative. And then I know firms that are out there essentially to get you, basically. You step in line. I've been on the receiving end of another firm not doing the right thing, and I'm asking my client permission. I need to call these guys and let them know that they're about to walk into a minefield. Where I could have done the opposite and just be like, all right, ha ha ha, that's terrible. I don't want to do that.
The contractors like you, or are you well received by the contracting community?
Yes. I mean, but that's again, not the company.
I didn't say facade consultants. I said you.
Exactly. Yeah, not every facade consultant, and even within our team, all of my team members have different relationships with people, right? So I remember when I was with the old firm 20 years ago, they said we evaluate not just your performance, but also how many complaints we get about you. For me, it was easy. I kind of get along with everybody. I'm very just let them do, and I'm going to come back. And I would use my boss as the bad guy too. I'd be like, my boss is never going to accept it. Let me go call him. And I call him and I said, these guys are screwed up. I'm going to tell him you said no. And then I come back and say, my boss said no. But I'm the one disapproving. If I'd always tried to keep the relationship with the field guys on the up and up. Today, I think I've told you this before, most of our clients are people that we've known for 10, 15 years. You can't do that pissing people off, basically. You're not going to have relationships. Let's
say you're representing an owner and trying to vet contractors, and you have 5 bidders and he's considering the bottom 2. So you've heard questionable things, you've been on problematic projects, but they're still in business, and they're still, I don't call it thriving, but surviving. How much of a factor does longevity and how long they've been in business come into a play? Let's say you have a business that you've heard, 7 out of 10 reviews you get are negative, but they've been doing it for 40 to 50 years. how else would they be able to survive that long unless they were either doing something right or they have to have a willingness to clean up their mistakes?
By then, it's more than, because again, are the complaints the product? Are the complaints the team? Or the complaints, just installation, that kind of thing. So it really would depend on that. So somebody that's been around that long, you kind of know what their problems are, right? And in Spanish, you say, más vale, what is it? Malo conocido que bueno por conocer. Basically, I don't know how to translate that. So the idea is that, yes, they might not be the best, but the unknowns of the other three guys that are maybe at the higher price point, you haven't worked with those guys. They haven't been around so long. So somebody that's been around that long, you kind of know what their problems are. So you come back to the client and say, look, this is the good part. Here are all the bad parts. You will have to have additional supervision here. I've even told clients, make a fund for, I don't know, for this type of failure or that type of failure. Or ask them ahead of time for this because they may not be able to produce it. Or they may have to sub this out. Or I've just said, this portion of the project, don't give it to them. They cannot do this system. They can do that side of the building. They can't do this. So
what happens when you come back and say, we want 40% more field tests? We want, 30% more time site monitoring. You don't do that?
No, because we already, especially for glazing, we already get special inspections. So you're getting 100% of the window inspections. The projects that are like rentals and things like that, where the client gets structural to do the inspection and structural only looks at anchorage, those, we warn them, but the risk is lower, right? But if it's
what about inspections in the shop before it shows up on site?
We're not doing those as much. We don't get a lot of structurally glazed systems. Structurally glazed systems is required by code. Inspections in the shop, and they are on the window guy to do. The owner doesn't necessarily have to hire it himself. The window.
So isn't that strange? Let's scrutinize once it shows up to site, not when we can catch the issues early on, right?
Yeah. So, but again, you're describing firms that are mass producing windows, and that usually the failure points aren't at the shop; they're more in the field, right? These mass produced systems are kind of cookie cutter, right? Repeat.
Well, that's interesting because most of special inspection in New York does require shot monitoring. And I guess maybe that's more in the custom-oriented systems. But I mean, who's monitoring the glazing, deglazing? Who's monitoring the insulation that's going in the back pan? Who's monitoring the IGU before it's glazed itself to make sure there's no blemishes? So sometimes I think there's almost more to check in the shop than in the field. I mean, in the field, you're just checking your splice seal connections, essentially. That's probably what's most critical.
So I guess historically the failure points we've had are more field, less fabrication. But that doesn't say, again, if I'm doing a curtain wall system, especially if I'm doing a custom curtain wall system, yes, that we're going to recommend that you have somebody at the shop following them.
Well, all your window wall going up in Florida, it's so field labor intensive that's probably even more critical, right?
The window walls have been simplified. If you think about it, they have the tracks. You bring them up with the winch, you lay them in place, and you anchor top and bottom, and that's about it. Then you have to go on a swing stage and seal the outside. But you just need somebody that can install a perimeter sealant. So it is
but that's a big ask on a single line of sealant on a barrier type system. That's what I'm primarily talking about. Your perimeter caulk joints on the receptors.
Yeah, those are your failure point. Those are your 1% that's going to fail in the entire facade. Is all those sealant lines, which is why we're discussing: can I do double? Can I do 2 of those, like I would do on a precast panel or something like that? They're going to laugh at us and say, nope, it got beat out, but it's a possibility to do it and still keep the traditional kind of window wall system that it's used to.
Like go cheap on the sealant, the thing I don't know. It just out of everything to VE on a job, especially a high-rise building in Florida and exposed to super high wind loads with wind-driven rain, it seems like astronomical.
There's one last fight I want to pick, and this might get me in trouble. After the Champlain Towers collapse, one of the changes was to laws, right? So now you have these condo laws, and they have to do assessments and structural assessments, and they have to have money in place to essentially fix an existing building. To my knowledge, there hasn't been an upgrade in the codes or in the laws to the design of the buildings and the systems, right? So now you're putting the burden on the future tenant of the condo that he has to keep funds to fix that building that was done with a single sealant line, that was done with potentially the cheapest contractor. And the way is, if it lasts 7 years, then 7-10 years, you kind of missed that 558 clause claim. But that to me is again one of those things that this doesn't make sense. We can make the existing buildings have funds to get better, but we should definitely improve on the new buildings, because we know for a fact they're not lasting 40 years. We know they're not lasting 20 years. So, you know, I was told that I'm going to ruin the industry if I push for that, but you know, I think you said they said that about, or I said they said that about impact windows. Nobody was going to pay for impact glass, and now it's just like you don't do anything but impact glass. So we'll see how it goes.
I'm going to clip this last part and blast it all over the internet just for you. Well, thank you both for coming on. That was fun. We didn't really dive into passive house. Maybe we'll do a round two, but this is a great group.
Be great.
Nice to talk to you.
Appreciate it. Yeah, good to talk to you as well. Take care.
Thanks, guys.